Good afternoon, everybody. Thanks for joining us for the California Fire Science seminar series. My name is Andrew Johnson. I'm a PhD student at UC Berkeley in Scott Stevens' lab, where I study the human dimensions of fire management. I'm also a member of the student committee who assisted with planning this webinar series, and I will be your host for today. California Fire Science Seminar Series is organized and supported by the Berkeley Fire Research Group, College of Engineering, University of California, Berkeley, the University of California, Merced, and the California Fire Science Consortium. Before I introduce today's speaker, I'll go over a few housekeeping items. This webinar is going to be recorded and will be posted on the California Fire Science Consortium website and YouTube channel. All registered participants will be emailed a link to this recording once it's available. This typically takes around a week. This email will also include a brief evaluation survey we hope you'll complete, as it helps guide the development of these webinars in the future. So now, without further ado, let me introduce our esteemed guest speaker, Dr. David Calkin. Dave's a supervisory research forester at the Human Dimensions Program of the U.S. Forest Service Rocky Mountain Research Station in Missoula, Montana. He co-leads the Wildfire Risk Management Science team, working to improve risk-based fire management decision-making through improved science development, application, and delivery. His research incorporates economics with risk and decision sciences to explore ways to evaluate and improve the efficiency and effectiveness of wildfire management programs. In 2023, Dave received the Ember Award from the International Association of Wildland Fire for sustained achievement in wildfire research. If you'd like to see Dave's publications, you can find them on Google Scholar, or if you don't have access to a lot of articles on Google Scholar, they're also available on TreeSearch freely. Today, Dave's talk will be about the role of economics in wildfire risk management. Following Dr. Calkin's presentation, there will be a Q&A session. Please feel free to add any questions you have to the Q&A chat throughout the presentation. Now, please join me in welcoming Dr. David Calkin.
Yeah, thanks very much, Andrew, and glad to be here. Really appreciate the invitation. Want to start out with a disclaimer. Despite having a PhD in economics, I really don't consider myself an economist anymore. I've kind of evolved and moved into different realms of work with foci on risk management, decision making, hopefully some systems thinking thrown in. But through it all, I think the economic thinking, has informed a lot of what I've done. On this slide here, just kind of demonstrating 4 really significant values that are impacted by wildfire: communities that burn up, watershed degradation, the firefighter well-being, the mental and physical well-being of our firefighters. And as we're starting to really see emerge is the physical health associated with smoke experiences. All right, now how do I, there we go. So here's an outline for the talk today. I'm gonna just start off with some key definitions so that we're all working from the same page. Briefly describe some early work I did in my Forest Service career that helped me understand the challenges associated with fire management. Then kind of the emergence of wildfire risk and how we can spatially and quantitatively assess those risks across space and time. Have a little bit of a discussion of the culture, expertise versus the analytics. And, obviously as researchers, we're heavy on the analytics, but within fire management, expertise kind of rules the day, up until recently at least, and probably still going forward in the future. A key role for economics is performance measurement. Are we getting what we want out of this, what we're investing? And then kind of finishing up with the challenges, wicked problems and systems thinking, and how that kind of can inform how we go forward with this very complex problem. To start off with, most of you have probably seen this. This is the logo of the cohesive strategy. And the cohesive strategy has been around for about 10 years. It's a framework around which partners have come together, both different levels of government, but also nonprofits and communities, to move forward collectively in reducing wildfire, negative outcomes associated with wildfire, or living with fire, as a lot of people are often talking about it now. And here they've identified three specific goals. The first is resilient landscapes, and that's basically the health of our wildlands, the ecosystems. And this is really where much of the historic science has existed. While we were transitioning away from traditional burning, the scientists were recognizing that there were going to be some ecological challenges associated with removing fire from the system. So this work has been going on for 100 years plus. Fire adapted communities, again, this is more recent, but there's a lot of investment, particularly in the social sciences, understanding the characteristics of communities, their risk perceptions, and how their risk perceptions drive the mitigation work they do, as well as thinking about their response and recovery to events. And what our team has largely argued is this safe, effective, risk-based wildfire response is largely ignored in much of the work to date. It's kind of understandable because it is more of a means to the ends of the other two objectives. But our argument is that, at least in the recent past, this has been the biggest component of our response to wildfire. It has both sustained the burden of the bad decisions we've made in the past, but also can perpetuate those decisions going forward. And there's a lot more decision space here than people recognize. Unintentional ignitions are going to be the biggest action, the biggest disturbance on the landscape, far more than our intentional actions. And how we respond to those has a lot more opportunity to change our future than most people recognize. And that's where we've focused a lot of our effort. And much of this talk will focus on that response side of the system. So just some really simple definitions. A lot of times when an economist comes in to talk to somebody, you think we're going to put dollar figures on everything. And that's hopefully not the case here. And so I like the broadest definition of economics is simply the study of how individuals, businesses, and governments allocate scarce resources. Another important definition, and this is kind of the economist's view of government, the function of government. And it's to correct problems of market failure associated with public goods, external costs and benefits, and imperfect competitions. Particularly relevant for this work is public goods, and those are things like defense, national defense, highway systems, firefighting response, clean air, clean water, etc. External costs and benefits are basically when the actions of one player, of one actor in the economy, has significant influence on the well-being of others. And so the external cost and benefits, the founding of the Forest Service was based on the fact that rampant clear-cut logging in the West was having extreme negative impacts on the quality of our water. And that's kind of where the Forest Service emerged from, is recognizing those external costs and benefits needed government intervention to get us to a better solution. And then finally, risk, the effect of uncertainty on objectives. And this is kind of the International Standards Organization 31,000 report. It's an incredibly simple definition, but it belies the complexity of actually applying it to management problems. And we're going to spend most of our time today in this world. And so as I was coming out of my degree in the early 2000s, there were kind of three different schools of natural resource economics. The first was kind of free market economics and recognizing the inherent inefficiencies of government. If we just assign a property right, those impacting others and those being impacted can just negotiate to a level of appropriate damage and mitigation, and everything will be fine and dandy. Unfortunately, there's some really big assumptions that you have to make to assume that that will occur, and one of which is perfect information amongst all of the players, nobody utilizing political power for their own benefit, and then also being able to aggregate everybody's interests into kind of a common metric of money. So collectively, we would all have to come together to decide how much pollution we wanted, and then we would pay the the coal mine, the coal distribution and system to give us that. And so we would have to make payments, and yet there's all sorts of problems with that. Non-market valuation was a really significant field in the early 2000s, and it was basically based on the assumption that people could articulate their interests in natural resources and these non-market, non-monetized values through surveys and through observation of the decisions they make. One of the big assumptions there was the cognitive burden of understanding all of the different things that nature gives us and trying to put values to that by simply asking somebody, how much would you pay to have better air? It's really a huge cognitive burden. And the emergence of behavioral economics has really kind of recognized that that cognitive burden is far more than most people can handle. And then kind of the school I came from is simply trade-off analysis, that the best we can really do is describe all of the different values that are out there in their natural units and explore what one alternative gets you in terms of a bundle of goods relative to another, and kind of utilize the best we can to get the best deal we can collectively. So hopefully those definitions will help understand where I'm coming from in the rest of the presentation. So this was one of my first efforts as a Forest Service employee, is supporting my colleague Krista Gebert in developing a cost model for large wildland fires. I joined the Forest Service in 2002. 2000 was kind of a really significant fire year where fire costs really started to become substantial portion of the federal land management agency's budget. And so Krista had gone out there and started collecting large fire cost data. And this was kind of the first national model of what drives fire suppression costs. It was really significant, at least to my understanding of the problem, for a number of reasons. First, the cost estimates were had a large amount of uncertainty around them. A fire could cost twice as much as as our model suggested, and it still would be within one standard deviation of what you'd expect on the within the stratified cost index. Another is that data is rare and weak in a lot of times. One of the key drivers of fire cost is how the fire evolves over time, how long it lasts, and what risk it poses throughout the event, not just at ignition. And yet those data were largely absent. Another interesting fact about the stratified cost index is over time it became a congressionally reported metric. And so every year we would evaluate all of the large fires on federal land and produce a report showing how much they cost relative to what was expected. And that was every year we would report it to Congress, and every year we as an agency would not utilize it at all in understanding what was going on these different fires. And what I found was that it actually was a pretty decent coarse filter that would identify those unusual fires that had something going on that was worth looking into. And yet inherently the performance management or performance measurement side of things wasn't followed through. Another really seminal piece of work was the Fire Program Analysis Project. And that began in I think it was around 2002, with an ambition of identifying the optimal location of every suppression resource on the land to most efficiently respond to wildland fire. There were some real significant challenges, however, one of which the fire modeling basically was not that advanced, and we had to assume a single fire season. Another challenge is we had to bring in multiple levels of government and different specific agencies and get some consensus on what the values were that we were trying to protect. Another interesting one is the challenges of contracting within the federal government and software development. And then finally, the reality of a sunk cost bias within the government. This program sorry, I missed one other key point. Essentially, we don't really know all of the suppression resources that are out on the landscape and where they are. When we started this project, there was some available information for federal resources, and through significant effort, we were able to get most of those federal resources identified with their location and what types they were. However, all of the non-federal resources, which are significant in the fire response system, still don't exist in a common database. So there's some real challenges in where those resources are. So from that, we did eventually kill this program in 2012 after probably $100 million of investment. We really never got to a solution, but there was significant work in salvaging the parts. And a lot of this was initiated by Mark Finney out at the Missoula Fire Lab. And this was his first effort in defining wildfire risk in 2005. So this was, almost 20 years ago. Mark outlined that risk can be quantified. Wildfire risk can be quantified as the expected change in values. And we need to sum that across the full range of fire intensities and a full range of values that will be impacted. And the way we do this is the probability of fire of a given intensity times the impact to value J, the specific value, and that's both the benefits and the losses at that fire intensity, because we know the consequences of fire differ based on fire intensity level. So this was kind of the first quantitative definition that I know of for wildfire risk. And from that, we were able to develop a bunch of different tools. And I don't know if Mark was just prescient in, understanding what was needed and then went and developed it, or if he had it in his pocket and he just needed some way to start introducing it all. But essentially, Mark was able to develop those probabilistic fire models that both identified the probability of fire reaching a point on the landscape and the intensity under which it would arrive. And so this was a major significant advance. It was based on basically increased computing power, and it allowed us to play out different futures. And we started with the FS Pro model, and that's starting with a large fire. Typically, a large fire recently escaped. You would model the perimeter, and then Mark was able to develop a Monte Carlo simulation of 1,000 different potential futures for that specific fire, and you could map it out over time and see the probability of fire reaching any point in the landscape for up to 14, 20 days even. What we did was we started going, okay, that's great, but let's start thinking about that risk. Let's think about that consequence to the values. And here we overlaid a number of different resource values, including structure, location, major infrastructure, and a number of different resource values. And this was the foundation of the Wildland Fire Decision Support System in 2007. Again, kind of reflecting on the challenges of building software systems in the government, contracting challenges. This system was built up and institutionalized in 2009. It still exists almost in its original format, and that's one of the real challenges we have. But it was the first time where we could really compare relative risk across different fires burning at the same time, which was a major advance because in a lot of the situations where we are managing fire, there is an incentive to overstate the risk so that your fire gets the most resources possible. One of the other interesting lessons here is that translation of these analytics to the field and how to interpret this information is critically important. One of the first lessons we experienced was looking at, after people would get this information, they would report structures threatened out to the very lowest probability zone. So the 1 in 2,000 fire event would have 10,000 homes potentially impacted. Extremely unlikely that would ever occur. And yet in that 209, instead of reporting 1,000 structures, which was grossly overstated, they'd report 10,000 structures. So again, that translation of science becomes a really important thing to consider as we build up risk-based tools. The FS Pro model that was the foundation of WFDS was for a specific event. So you basically had to have a fire perimeter as a starting point and a date for that so that you could build out the fire weather going forward. The next extension to this was the FSIM burn probability model that basically covered the landscape in ignitions and then built millions of different potential future fire seasons and burned these fires over different lengths of time. And from that, we were able to get a map of the likelihood of any pixel in the United States burning and the intensity under which it burned. With that information, we could then move into a risk-based framework where we really look at the consequences to the values that are impacted by potentially impacted by a wildfire. And these are a couple of the seminal documents. The first approximation was developed in 2010. That's basically just outlining how we take probability of fire, intensity of fire, and the impact and the resource values, and put it forward for a national assessment. This document on the right is GTR 315, and it's kind of the Bible of how you do these risk assessments. These risk assessments have been done at multiple states. There are very similar practices in other countries, but it's basically become the gold standard of risk assessments. And one of the key factors here is this HVRA characterization. HVRA stands for highly valued resources and assets. And this is where we get the consequence of fire. And so the upper two maps here are probability and fire intensity level. And the lower one is how we characterize the HVRAs. First, it starts with identifying the primary values at risk spatially. From that, we work with resource specialists to come up with response functions. How does this value respond to flame lengths of 3 feet? How does it respond to flame lengths of 6 feet? And using their expertise in their specific resource value, they can identify ideally how that resource will respond to fire, both from a positive standpoint and a negative standpoint, recognizing that lack of fire on our landscape is a critical gap that we need to address. So how can we identify where on the landscape fire is a good, while we recognize also those places where fire needs to be kept out to the best of our ability, or the landscape modified such that the intensity is reduced. And then finally, that prioritization process is left with the leadership team. We don't want to ask the wildlife biologist how important frogs are. We know their answer. It's the leadership role to kind of value habitat versus watersheds versus structures, et cetera. But with that, we are able to kind of develop these risk maps. There's some real challenges with the values. It's fairly coarse, but it gives you kind of a heat map of where things go. When it gets to mitigation, there's a lot of different ways that we can take these risk assessments and bring them down and understand how mitigation can change that risk going forward. From that, while we were doing all of this risk assessment work, I got voluntold to participate in the Four Mile Canyon fire. This was a 2011 fire outside of Boulder, Colorado. Several hundred homes burned during this event, and the state and the local community wanted to understand what happened here and what could they learn from this event. And so I participated with a team of Forest Service researchers. And when we got down there, we spent several weeks looking at the fire, understanding the fire. And one of the team pulled up a review from 20 years ago, 20 years prior to this event, of the Black Cat fire. And we read the executive summary, and it read almost perfectly to what this fire was, with the exception of the dates and the number of acres and the total number of homes burned. But the event itself was eerily familiar. And yet this community itself had engaged in some pretty significant fuel treatment activities and had been working on the home ignition zone a little bit. And so through this review, I worked with these other co-authors to really try to distill it around a risk-based framework to see if framing it differently, framing this problem around risk management, might help us move forward. And one of the things we started with was the disaster sequence. The events that cause the most damage are have severe wildfire potential. Significantly windy events, very dry, and the landscape is set up for these rapid fire spread events. Also very important is under these conditions, suppression is very rapidly overwhelmed. We're not able to stop the fire. We get into a triage mode where we're trying to look at how to evacuate people and, if possible, keep structures from burning. However, under these conditions, if there's multiple vulnerable structures and how quickly these events emerge, that suppression is overwhelmed and multiple structures start igniting, and they become the fuel for future structure ignition. So recognizing essentially that the risk resides under the extreme events, and in these in the mitigation work that had been done to date in this area, the assumption was that this work would be successful under 85th percent weather conditions. Well, we had 99% weather conditions, and this 99% weather condition is where all loss occurs. So how do we think about mitigation under the most extreme events? And one way to do that is to really further kind of distinguish what we have control over and who owns the risk and who can most effectively reduce it. And so on the left-hand side of this kind of flow chart, we recognize that the land management agencies largely have control over ignition prevention, fuels and veg management, and preparedness and suppression response. These are easily overwhelmed under extreme conditions. How we deal with the consequence of this event is on the right-hand side, and that's by basically not building in the most hazardous areas or restricting how homes are built in those most hazardous areas. And then also Jack Cohen's extensive work on the home ignition zone. The owner of the risk is the most capable at reducing loss under the extreme events based on the condition of their home and the home ignition zone. So this hopefully started us thinking about the role of traditional fire management, fire and fuels management, in addressing these consequential human community disasters. Another important finding that we were working on at the same time is that most of the risk to these communities is in fact coming from non-federal lands. This was on the left-hand side, a study Jessica Haas, myself, and Matt Thompson did where we simulated ignitions on the Front Range of Colorado and found that approximately 90% of significant community events from a simulation perspective started on non-federal land. And this was confirmed over the last couple of years by Will Downing and Phil Higuera looking at the recent fire disaster events, again confirming that human ignitions on non-federal land is where those community destruction events come from. So again, that helps us to challenge, risk management has helped us to challenge some of the fundamental assumptions around how we approach wildfire management. So next, I want to talk a little bit about this clash of cultures, the experience versus analytics. And this is a quote from the great Charles Barkley: "Analytics don't work at all. It's just some crap that people are really smart made up to get into the game because they had no talent." And I'll take Charles Barkley calling me really smart with no talent. But I think it is representative of some of the challenges we have when we come as researchers into the fire management world. Fire managers work through the system based on their experiences. It's a very experiential learning environment. And these task books basically build through your experiences. If you've done this, then you've experienced it. Therefore, you're ready to go on to the next step. And so analytics assessment aren't really valued in that community very much. And that's kind of brought up in an academic way as well, with kind of two very different approaches to the world. Gary Klein on the left and Daniel Kahneman on the right. Both of them are psychologists. Gary Klein's work is, Gary Klein's best known for his work in recognition prime decision making. And basically that is through experiences, experts can come up with rules of thumbs and heuristics that allow them to do very complicated tasks very, very well. Well, Daniel Kahneman, again, another psychologist, however, he has a Nobel Prize in economics for his work in behavioral economics. And his approach is that humans, when confronted with uncertainty, are fundamentally flawed, and there are consistent biases that we all express when we are confronted with risk. And they're understandable, but the only way out of it is to kind of stop and to think more deeply, because our heuristics and because our gut response is usually wrong. Well, these two appear to be completely on other sides of the fence of this problem, but in 2009, they came together and wrote a paper called Conditions for Intuitive Expertise, a Failure to Disagree. And what they did here is basically identified the characteristics where experts are highly successful, and also those conditions where experts largely the application of expertise largely results in suboptimal outcomes. And this really is kind of a synthesis of some work that James Shanto had done in the early 90s on competence in experts, and characterized those conditions where expertise results in good outcomes and where it doesn't. And some of the key predictors of whether expertise results in good outcomes is whether the decision is static, whether it's repetitive, whether the stimuli are predictable, and whether or not people use decision aids. And so if you look at those characteristics, they're largely absent in the large fire response world. So reliance on RPDM is likely to result in suboptimal outcomes if that's our primary focus in how we develop large fire strategies. So with that information, what do? And this was kind of our team's efforts over the last 5+ years. How do we bring in that local knowledge and local expertise and the people who are going to be confronted with these problems with analytics to help look at different alternatives and try to find good solutions to this very complex problem? Further, through this work, how do we get all the partners engaged and get expectations set so that when smoke is in the air, it's not trying to tell our story of this fire is being managed in this different way than you expect and deal with some smoke and some uncertainty. Trust us, it is, you are here, you've gone through this effort with us to understand how we are going to best be successful on the landscape. This is the PODS process that we've developed. It's called the Potential Operational Delineation. And it starts with a risk assessment. Where are those values at risk that are likely to be impacted by fire, and how do we consider them in our mitigation response? But it very importantly brings in that wildfire response world. Where can these wildland fires be successfully engaged in a safe and effective manner? And this really took off through Kit O'Connor's work in developing the potential control location model and the stratified and the suppression difficulty index. So we were able to bring maps together, bring maps out in collaborative settings to kind of center people around where are the problem areas and what can we possibly do about it, and kind of pre-identify those places where we're most likely to be successful, and also identify those places where we have high values at risk, but right now are not set up for success. And that can really inform the mitigation strategy. This has been incredibly successful. We've gotten major investment in this work through the bipartisan infrastructure law. Numerous people have been hired both within the Forest Service as well as a number of universities and collaborators to help get this work out into the field. And it really sets the stage for better fire management and allows us to think not of how are we going to stop this immediate fire, but how does fire response play into this larger fire management challenge. While we were doing that, we were also working with individual incidents, large complex incidents, and trying to bring analytics to the field. This was the Risk Management Assistance Program. It started out in 2017 with an intent of really helping line officers understand alternatives that are posed by different fire events. What we learned fairly quickly was that developing these alternatives, robust alternatives for line officers to consider, was time consuming. And by the time the work had been done, the incident teams were kind of already going, and it was very difficult to turn the ship. So it was kind of, in some regards, our initial attempts were something of a failure. But through the delivery of these analytics, many of the same analytics that informed the pods, we were able to engage some of the really thoughtful incident responders who had been asking some of these questions and thinking about these problems in similar ways. And they kind of started to utilize these different maps, and it really helped them inform their strategy and think differently about the problem and challenge some of their assumptions and identify, like, oh, that's really bad. We're asking a lot of firefighters for this strategy, but we're not getting much from it. So this was really an important learning process. And this dashboard is a huge value to the field, and it's available to everyone, and anybody can go in there and understand a lot of the different tools that are in there and some of the different analytics, and download and use them yourselves. But a very successful program over time. And this is really a very cool application of that RMA work. You know, the RMA work was put out there for people to consume, but there really wasn't an effort to help structure how this different information could enter into a strategy development process. There was kind of descriptions of what it was and what it wasn't, but how it fit into a framework really was absent. A number of operations section chiefs started to come together and have these discussions about how they were using some of these key RMA analytics in developing their strategies, as well as some work in identifying values at risk and having better conversations between incident teams and agency administrators around values at risk. And so this is what came from all of that work over the last 3 years. It's called the Incident Strategic Alignment Process, and it has 4 pillars, one of which is the critical values at risk from fire. From that, like, how do we develop possible strategies that are feasible? And when we look at feasible strategies, what are the implications to responders? We're trading off protection of values with risk to our responders. And then finally, probability of success is hugely important. How likely are we to be successful in protecting those values? What are the implications to our firefighters? And how do we find that alternative with the best outcome? And again, it sounds a lot like a quantitative risk assessment. We have probability, we have values, and we're examining an alternative. This has really gathered a lot of momentum. There are teams that are going out and training all of the incident teams on this process. And it just so happens to align very closely with the PODS work. It shares a lot of this underlying analytics, and conceptually very similar as well. So we're kind of approaching the problem both from the planning, the landscape planning side of things, as well as the wildfire response side of the problem. Key performance measures. I'm going to brush over those really, really quickly, but it's an important component where economics can help us make progress in understanding what's happening on the landscape and promoting learning. But it's difficult. This is just recognizing that when we look at fire cost, for example, or fire outcomes, there's both a forest component, the landscape, and the decision makers on that landscape, as well as the incident team that gets assigned, all have significant influence on fire outcomes. This is the Dixie Fire. Many of you from California may be recognize this event. What this is just a fire line effectiveness examination. How much line was built? How much line was built that held? How much line was built that never engaged the fire? And how much line was built that burned over? And this shows that less than 20% of all line built on the Dixie Fire actually held. And you can see that there was this persistent, let's try the next ridge, let's try the next ridge, let's try the next ridge. And there's huge implications when we take that approach. And this is just a kind of infographic we developed that basically over the course of the event, 360,000 person days were assigned to the Dixie Fire. One crew member working for 1,000 years. At one point in time, 1 in every 4 suppression resource was assigned to that event. And the cost of the Dixie Fire in 2021 exceeded the entire hazardous fuel budget for the Forest Service that year. And so when we have these low effectiveness events, it has huge implications to our response system. And as we recognize the mental and physical health implications to our firefighters, we really have to rethink these kinds of responses. So kind of finishing up, wicked problems and systems thinking. Wicked problems are a type of problem that I think fire management fits into. And essentially, a wicked problem is a problem where there is no definitive problem definition due to incomplete, contradictory, or changing requirements. One solution may reveal or create additional problems. Wicked problems are usually symptoms of other problems, and there isn't an optimal solution to a wicked problem. So I think if you really kind of dig into the fire management problem writ large, you'd recognize this as a wicked problem. But just because wicked problems can't be solved to optimality, and these problems will persist over time, does not mean that we can't do better. And that's, I think, the role of systems thinking. And how do we really evaluate the whole and what we can do about that whole and how that informs our organizations and our approaches to the problem. This is a recent paper I authored in Proceedings of National Academy of Sciences, working with a lot of the co-authors from that earlier 4 Mile Canyon review that we did in Proceedings of the National Academy of Sciences. And basically 10 years afterwards, what have we learned? And what we've learned is these types of events are becoming ever more frequent, and that our approach to preventing them really has to start from the inside out. And that traditional fuels management on public lands and fire suppression resources will not get us out of this problem. And so that's just basically saying our problem definition. If we define community destruction as the primary challenge of wildfire management, our mitigation strategy is pretty backwards at this point. Additionally, thinking about 3 really important documents that have come out in the last couple of years. The wildfire crisis strategy that the Forest Service authored. 3 primary points from that: a goal of treating 20 million additional acres on federal lands, 30 million additional acres on non-federal lands, and enhancing the capacity of the workforce in this environment. What we've seen from the Forest Service's implementation is a heavy focus on those 20 million acres of federal lands. The 30 million acres, we could argue, is more effective in protecting communities. And how we coordinate that effort is going to be a huge challenge, and it's going to be very expensive. And there really isn't an organization or a government agency responsible for that work. Capacity is a huge challenge right now. Workforce capacity, people interested in getting into fire management has been limited. And so the economic realities over the last few years, people have other options than the incredibly difficult, challenging, and physically and mentally demanding work of fire response. National Cohesive Strategy, 10 years on, created an addendum. And one of the things I really appreciate about that is really emphasizing that fire adapted communities, the way to achieve that is to prepare communities to receive, respond to, and recover from wildfire, not to prevent wildfire from impacting them, but preparing them to deal with it. And then on the right-hand side was the Wildfire Commission report, presidentially, I guess it was required under the bipartisan infrastructure law. They developed a commission, had 49 people come together. They offered 154 different independent recommendations. Not a lot of information on how you prioritize those 154 different actions. And they really didn't take a systems view of how do we move forward with a different approach to this incredibly challenging problem. So just in summary, how can economic thinking help us to better live with wildfire? We need to understand the impacts. I think smoke impacts are going to emerge as massive, particularly after the Canadian events last summer that impacted the heavy population centers in the Northeast. We need to define the problem differently. We can evaluate mitigation strategies using key performance indicators, but we also have to think about organizations that can better resolve some of these inherent challenges. Where does it exist? How do we develop them? And how do we change the organizations and culture that we already have in this problem, working in this area? So that's it. Happy to address some questions.
Great talk, Dave. Thank you. Thanks for your presentation. Yeah, we'll open it up for Q&A now. Due to time constraints and high attendance, we ask that all questions be submitted through the Q&A chat. If we're unable to get to all the questions, we'll forward additional questions to the speaker and hopefully send the answers in a follow-up email. So our first question, Dave, can you speak at all to the type of risk models and how granular they are that the insurance industry is using to evaluate property risk?
Yeah, I haven't delved much into the insurance industry risk. The folks that I've talked with who have say they're pretty coarse. And I think that's a real challenge. So it's almost like a zip code approach of influencing the premiums. And I know in California, we've had two major insurers leave the market completely. Due to the challenges of having rates that align with risk. I think that's an incredibly important component of how we move forward for the risk, for the insurance companies to define what a effective home ignition zone looks like. What does a mitigated structure look like, and how can they identify those rapidly and also adjust premiums to make that work valuable and incentivized. And once we get there, I think that's probably going to be one of the most positive factors moving forward, is getting the insurance companies to define what they need out of homeowners such that they can stay in the market and give reasonable rates and give people the value for what they're investing in protecting their homes. So a huge area for opportunity. My understanding is the insurance companies have not gotten very granular yet. Some of the work we're doing may be at a finer scale, just at least from the probability of fire. The consequence we haven't done much with at all.
Do you know if they're still relying on the same spread equations that we do?
I think it's all kind of their own models, but I think they're pretty smart in grabbing what data are available, and if they can tweak it or change it for their interests, they will. I mean, there's huge markets on the line here, so I have not heard that there's fundamentally a better spread model that has come out of there that is challenging kind of the basic models that Mark Finney has developed. And yet recognizing that those basic models are just simply math equations of how things spread, and that our ability to really observe or simulate how treatments change outcomes, still, again, that granularity is a big issue.
Thank you. Next question is, can you speak to the to any projects that are looking at variable dependence and codependence within the existing models, how this influences most of our fire modeling tools?
No.
Okay.
Yeah, so we've really focused on the delivery of information to the field to inform decision making. The actual kind of what drives these models, I think, points you to Karen Short, Mark Finney, and some of the others who are really looking into those issues. I apologize.
This next one is perfect. Can you speak more to how these so this person's interested in HVRA characterization and response functions? Can you speak to how those response functions move from qualitative to quantitative, and is this process iterative with experts?
Yeah, so we've been working at this for a number of years, and basically we started by going to a specific location and going, here is a watershed. How will it respond to flame lengths of 2 feet? And we started with the baseline value of its current condition, and that's 100%. And so if it's going to improve, it's going to be a 50% more improved watershed and more functioning. That would be a positive 50%. If it was going to be totally wiped out and really not function in its traditional way, it's 0%. So you can go from 0% to anything above 100%, and above 100% is that positive benefit from fire. And you do it for each different intensity level. What we have done is a number of folks, particularly at Fire Modeling Institute, have been working on an archive of all of the different values that have been incorporated into these risk assessments and how people have characterized those responses. And so there is a body of work. Typically, when we go into an area, we ask that the experts, the hydrologists, the wildlife biologists, et cetera, review the available literature on how those values respond to wildfire. And so that's kind of how that's evolved over time. And you go from that 0%, meaning total destruction, to something over 100%, meaning improvement.
Thank you. Next question is, so to what extent are multiple and sometimes overlapping jurisdictions in and of themselves a contributor to WUI, wildfire hazard, and risk?
Yeah, I guess that's a really important problem. And, one of the statements we're making is that a majority of the risk is coming from human ignitions on private land. And so that implies that we should start from the inside of the community and work our way out. And those will likely be the most effective ways. The Forest Service does contribute risk, and some of the major significant events have been large fires coming off of federal lands. So it's not saying it's all a private land issue, but we're arguing that if you start with the private lands, you start at the structure and work your way out instead of starting in the wildlands and working your way in, that is going to have a better return on investment from a risk perspective. The different jurisdictions, I think, are really challenging. I think if you think about the Marshall Fire outside of Boulder a couple of years ago in January, the community, county parks and the native vegetation played a significant role in transmitting fire into the neighborhoods. And then, the wood fences brought it to the homes, and then the homes brought it to the other homes. So I think we need to think about it very much across jurisdictions. And I think one of the traditional ways we've thought about wildfire management, particularly from the federal perspective, is how do we stop fire before it reaches our boundary? And through this PODS process, we're able to kind of build beyond that and recognize maybe the best opportunities are off of federal land. And maybe those are places where we can be safe and loss isn't really all that significant. Or maybe that's the only place we're going to be successful and it's going to be a really bad fire. So what are we going to do about it to prepare for it? So that looking across jurisdictions is really important.
Thank you. So earlier in your talk, you kind of talked about sort of data shortages. And this question is, What do you think the most important areas for fire management are to provide better data?
We're particularly interested in the large fire environment, where a lot of our costs are, where most of our losses occur, where our firefighters are run through the mill. Right now, we really don't have a good sense of what actions are being taken and how effective they are. We've kind of gone as far as anybody in this fire line effectiveness work, basically just looking at where these lines were built and reported, but we don't know why they were built there. We don't know if it was 1 dozer wide or 5 dozers wide or a hand line. We just know that there was a line built there. And so we really have a huge opportunity if we can better understand the specific actions that are occurring on wildfires, to understand which actions under what conditions are most effective, and then work with the incident teams to prioritize those kinds of actions in those kinds of locations. But right now, it's kind of, we built line and it worked or it didn't work. And that's only even been available for the last few years. Prior to that, we were left with, we had 500 firefighters on this fire for 3 weeks, and this is what happened. So huge opportunity in really understanding the effectiveness of different actions in different locations. If you think about that potential control location, that is probably the most important layer in the PODS process and in the RMA process. It assumes away wildfire suppression and assumes away fire weather. It just says these are the places on the landscape where fires have stopped in the past. Well, how influential were our actions in stopping them there? And when we think about mitigation and using the PODS process to set our landscapes up for success in the future, what do we need to do on these boundaries such that they will be really good control features, and that the incident team can come in there with the right resources? Now that it's been prepped, if it can be prepped ahead of time through the mitigation, they can then come in and get to implementation far faster and open up a lot of decision space.
Thank you. Another question here. Have you seen any of the tools presented used to determine response resource allocation? If so, can you speak to how that's being done? And this person's specifically interested in pre-positioning, but you can go broader.
Yeah, I don't think we've had too many discussions in pre-positioning. There has been some work in understanding these kinds of things to make the case for resource allocation. It's challenging when it gets into the GACs to under resource scarcity to get them to say, no, we are going to redirect here because of this opportunity, but we're working towards that. What we have seen is, like, under periods of scarcity, looking at 2 specific lines and going, yeah, we'd really like that closer line because there's value to be had there. But given the resources we have, we are going to have to fall back. And if we try to make a stand on that line, we have an assessment that we're likely to fail, and that effort will probably keep us from being successful in that next line. So on the individual fire, we have seen kind of, we're going to go here because of resource availability, and we're starting to try to use some of this information to inform GAC decisions on which fires get which resources. If you look at that FS Pro and values impacted, Rick Stratton and Ben Gannon in the Washington office Forest Service analytics branch are delivering these charts of, over the next 2 weeks, this specific fire has a higher likelihood of impacting homes. This one has, more difficult fire environment. This one has, watershed impacts. So we're starting to get to that position and trying new things out in that arena. We're not as far along as we'd like. And again, some of that is that culture of experience of the people assigning resources versus their comfort with some of the analytics that are starting to emerge.
Got it. Thank you. So that's all we have time for today. As we wrap up today's session, I want to thank you everyone for joining us. Special thanks to Dr. David Calkin for your presentation. Remember, our next session is scheduled for March 19th, 2024. We'll be discussing reforestation for resilience, creating fire adapted forests for the future with Mark Meyer and Malcolm North. Before we sign off, please keep an eye out for the webinar evaluation that will be emailed out this week. Thank you once again, and I look forward to seeing you all in the future. Have a great day.